Hi everyone, welcome to the course on chemistry. So in previous video we discussed about the structure of an atom, and now we will discuss about the elements and how the electrons and protons and neutrons are distributed in each and every element. So first, if we consider the hydrogen element, before that we should know what is element. The element, it is the group of same kind of atoms. Any substance which consists of same kind of atoms is said to be an element, and there are totally 118 elements are present, and in that 118 elements 90 elements are naturally occurring and remaining 28 elements are artificially prepared in laboratories. And now we will consider one by one the elements and how the electrons, protons and distributed neutrons are distributed in that element we will see. So first we will take hydrogen. So what is the atomic number of this hydrogen? Hydrogen, its atomic number is 1. Atomic number of hydrogen is 1. Now what does this atomic number means? As I already explained about the atomic number while explaining the structure of atom. So atomic number, it is the number of protons and neutrons. The atomic number is the number of protons which are present in the nucleus of an atom. Now here atomic number is 1. That means the number of protons in the hydrogen will be 1. This can be represented by at the center of the nucleus. As you know, the protons are present at the center of the nucleus. So this is nucleus, and if one proton is there, then how many electrons will be present in that atom? There will be presence of one electron, because as I have already told you, the number of protons is equal to number of electrons, and hence if the number of protons is 1, then the number of electrons is also 1. Therefore 1 electron is present, and that electron is present in first orbit and it is revolving around the nucleus. So this is the structure of hydrogen. Then if I consider helium, this is the second element in the periodic table and its atomic number is 2. Atomic number of helium is 2. That means 2 protons are present in the helium atom. How we can represent this? We can represent this one as, so the first you have to draw the nucleus. Then in first shell, how many electrons are there? If the 2 protons are there, then the number of electrons is also 2. Therefore the 2 electrons are revolving around the nucleus of helium atom. Then if I consider the another element, that is third element, that is lithium. What is the atomic number of lithium? 3. Therefore the number of protons will be 3, and hence we can represent it as, at the center we have to represent the nucleus, and in first shell how many electrons are there here? There are totally 3 electrons. Now can we write 3 here? No, because the first shell, its maximum capacity to hold the electrons will be 2, and hence there will be occupation of only 2 electrons takes place in this first shell. But here 3 electrons are there, hence that 1 electron which is present, it will move to next shell. So here we will represent the another electron which is present in the second shell. So this is how we will represent the structure of lithium. And then next, the fourth one is beryllium. Atomic number of beryllium is 4. So this is the symbol of beryllium and its atomic number is 4. Then how we can write the structure? At the center we have to draw the nucleus, and in first shell how many electrons are present? 2 electrons. And in second shell how many remains? 2 electrons will remains, and those 2 electrons will accumulate in the second shell. So this is how we can write the structures of atoms for all those kinds of elements: hydrogen, helium, lithium, beryllium, boron. Okay, what is the atomic number of boron? It is 5. So how we can represent this structure? At the center nucleus is there, 5 protons are there, that means the number of electrons is also 5, and hence in first shell 2, second shell how many electrons are present? Here the number of electrons present will be 3, because the second shell it has maximum capacity of electrons, that is up to 8. Up to 8 electrons it can hold, and hence we can fill up the electrons up to 8 electrons in this outermost shell. So just now it is 3, then 4, 5, 6, 7, 8, up to that we can write. Okay, similarly we can write the structure for all the kinds of elements. And here the electrons, as you can see, it is the outermost shell in the lithium atom. When we consider the electrons which are present in the outermost shell, these electrons are said to be valence electrons. So valence electrons means the number of electrons which are present in the outermost shell are said to be valence electrons. So in case of hydrogen, how many electrons are there in valence shell? Only one shell is there. So this is the outermost shell, and how many electrons are there in this outermost shell? 1. So the valence electrons, number of valence electrons in hydrogen will be 1, and in case of helium the number of valence electrons will be 2, and in case of lithium number of valence electrons will be 1. In case of beryllium number of valence electrons will be 2, and in case of boron number of valence electrons will be 3. So this is how the electrons which are present in the outermost shell will be named as valence electrons. Okay, and now the difficult thing in this representation of structure of element is, for smaller elements we can write the structure and we can mention the number of electrons which are present in the outermost shell. But in case of higher elements, to represent the structure of atom, it is quite difficult, because it takes time, lot of time, and also space. And in order to minimize this, we will write this distribution of electrons in a particular shell or particular orbit which are present in the atom by using the electronic configuration. We will use electronic configuration. So this electronic configuration, it simply represents how many electrons are present in the atom and how they are distributed in an atom. That will represented by electronic configuration of an atom. If I consider the hydrogen atom, so atomic number of hydrogen is 1. Now if you want to draw the structure, we can represent the hydrogen atom by this structure. Suppose I don't want to draw the structure, simply I have to write or I have to represent the electrons which are distributed in the hydrogen atom. What we have to do? We will represent that by electronic configuration. How we can represent it by electronic configuration? So simply consider this hydrogen atom. Okay, so at the center nucleus is present and one electron is present in this first shell or the outermost shell, because only one shell is there. Now how we can write the electronic configuration? Simply you have to consider the first shell, because the electron is present in first shell, and in first shell which orbital is there? As I have told you, orbital or subshell, it is the region where you can find the electrons most probably. Okay, so here the first shell, if you remember the subshells, those are S, P, D and F. Once again I will write that here. Okay, if you get confused, this is the nucleus, and in first shell how many subshells are there? Only one, that is S. And in second, S, P. Third shell, S, P, D. And fourth shell, S, P, D, F. So these are the subshells which are present in each shell. So remember these subshells. Now in case of hydrogen, since electron is present in first shell, which subshell is there? Only S subshell is there. So this electron should be present in S subshell, and hence that electron is present in first shell, okay, the first orbit. Hence we will represent it as 1, and S is subshell. Whether it is S, P, D or F, that you have to write. Since the electron is present in S subshell, I will write it as S. And how many electrons are there in S subshell here in hydrogen atom? It is 1. One electron is there, that you have to represent here. So 1s1. This is the electronic configuration of hydrogen atom. So this is how we can write the electronic configuration of an element or atom. Second one, consider the helium. As you already know the structure, okay. So atomic number of helium is 2. Here the structure is given. Now how we can write the electronic configuration? See here, electron, where it is there? In the first shell, and hence I will write it as 1. Then 2 electrons are there, and those 2 electrons are present in S subshell only, and hence I will write it as S, because in the first shell only S subshell is there. So S. In S subshell, how many electrons are there? There is a presence of 2 electrons, and hence the electronic configuration of helium will become 1s2. In case of lithium, here only observe first shell. How many electrons are there? First shell. So go one by one. First shell, which subshell will be present? Yes. How many electrons are there? 2. 2 electrons are present. Now it is over, but still 1 electron is there. In which subshell the electron is there? In second subshell. The electron in second shell, the electron is present. So write 2, second shell. In which subshell the 1 electron is there? Because in second shell, see, there is a presence of S as well as P. Where it goes? First it goes to S or whether it goes to P, that you should know. And to know that, we will use one principle, that is Aufbau principle, okay, which is known as Aufbau principle. Aufbau principle. According to that, he says the electrons are filled in the increasing energy levels. That means you have to write first 2s 2p, second shell, okay, 3s 3p 3d, in third shell spd are there, in fourth shell 4s 4p 4d and 4f are there, and next 5s 5p 5d, okay, and 5, fifth shell. So on, as we move on, the number of shells increases, 5, 6s, 7s, okay. Now the first electron is filled in first shell. Then again you have to draw one arrow mark like this. It indicates after filling in first shell, it goes to the 2s, and then again draw one mark. Then it goes to, first this arrow mark passes through 2p and then it passes through 3s, okay. Next again, then it goes to 3p and then it goes to 4s. Then first it goes to 3d and 4p, then 5s. So as you move, you will get 4d, 5p, here I can write 6s. So in this manner, the electrons are filled depending upon their energies, okay. The 1s is having lowest energy, and hence the first electrons are filled in first subshell, that is S, first shell, S subshell. Then it goes to 2s, then 2p, okay. It will be represented like this, okay. It goes like this, again it comes here, again it move through this, again it will go through like this, okay, just like snake it will move, okay. So first, now you are writing the electronic configuration of lithium. So here observe it, 1s2 is completed. Next S and P, two subshells are there. Where it goes? See here, the arrow mark has passed through which one? Next, after 1s, it moves to 2s, and hence the next electron will be filled in this. Here the first electron will be filled in first 2s, okay. How many electrons are there? 1. So the electronic configuration of lithium will be 1s2 2s1, okay. Next I will write the electronic configuration of beryllium. How we can write the electronic configuration of beryllium? I will write it as first shell, okay, first shell, S subshell, how many electrons? 2 electrons. Then second shell, okay, second shell, 2 electrons are there. Where it goes? Whether it moves to P now? No. First S subshell gets fills up, then it goes to P, because S subshell, it has the capacity to hold 2 electrons, and hence these 2 electrons are filled in S only, and hence we will write it as 2s2. This is the electronic configuration of beryllium. Then boron. Boron electronic configuration, see, first shell, in S subshell 2 electrons are there, and second shell, first it will fills up in S subshell. What is the maximum capacity of S? 2, and hence the 2 electrons gets filled up in S subshell. But here totally how many electrons are there? 5. How many electrons are filled? 4 electrons. Still 1 electron remains, and that 1 electron Now it moves to which subshell? P subshell. Which shell? Second shell, P subshell. That you have to write here. 2 second shell, P subshell. What number of electrons gets filled up? 1, because only one electron has been remained and that is filled up in P subshell. So in this manner you have to write the electronic configuration of these atoms. Let's see here. Once again I have written the above principle, and here these are the electronic configuration of hydrogen, helium, lithium, beryllium and boron. Next, the carbon. Atomic number of carbon is 6. So how we will represent the structure? So simply, no need to write the structure every time. You can use these two things. By using these two things, you can easily fill up the electrons or write the electronic configuration. Since the 6 electrons are there, what you have to do? First shell. Okay. So 2 electrons will be present. Next, where it moves? In second shell, S subshell. Again it holds 2 electrons. Then where it moves? To 2p. Okay. So 2p. How much you will write? You will write 2, 2, 4. How many electrons will be there? 6 electrons. So 2, 2 remains 2, that you have to write here. So this is the electronic configuration of carbon. Then nitrogen, its electronic configuration is 7. How you will write? 1s2, 2s2, 2p. 7 electrons are there. Now 2 plus 2, 4 electrons as filled up. How many will remain? 3 electrons. Will you fill up that in p orbital? Yes, we can fill that in p orbital, because S can hold 2 electrons, P can hold 6 electrons and D can hold 10 electrons, F can hold 14 electrons. So up to 6 you can write here. That means 1s2, 2s2, how much remains? 3, that you have to write. This is the electronic configuration of nitrogen. Then oxygen, what is the atomic number? 8. So 1s2, 2s2, 2p, next 4. Then fluorine, that is 9, 1s2, 2s2, 2p, 5. Then neon, atomic number is 10. 1s2, 2s2, 2p, 6. Then after neon, what comes? Sodium, atomic number 11. So how you will write the electronic configuration? 1s2, 2s2, 2p, 7. Can we write 7 here? No, because the maximum capacity is 6. So you have to write 6. But there are totally 10 electrons. But here, how many electrons are there? 11 electrons are there. So next one electron jumps to where? After 2p. Which one will comes? 3s. So it will move to 3s. How many electrons are there? 1. Because 2 plus 2 plus 4, 4 plus 6, 10, 10 plus 1, 11. Then next magnesium. Atomic number is 12. How you write the electronic configuration? 1s2, 2s2, 2p6, 3s2. Then aluminium. Atomic number is 13. How you write? 1s2, 2s2, 2p6, 3s2. Next, another one electron is there. Where it fills up? After 3s. Where it goes? It goes to 3p. Then 4s. So 3p 1. So this is how we can write the electronic configurations of the elements. These are some examples to write the electronic configurations of the elements. And in home you can try for next elements, that is silicon, then phosphorus, sulfur, chlorine, argon, then potassium, calcium, all those things write the electronic configuration. So this is all about the today's class.